Thank you. So, having gone through the introduction of keratoconus and the basics of cross-linking, I will take you all through the new and modern form of accelerated cross-linking, the science and practice. I have no financial interest to disclose. So, the original Dresden Protocol, as you all know, followed a 0.1% riboflavin and 20% dextran. The total energy delivery was 5.4 joules per centimeter squared, wherein the energy was delivered with 3 milliwatt per centimeter squared for a period of 30 minutes. So initially after the induction time and then the laser delivery time took a very tedious, more than an hour's period and a prolonged treatment duration, especially for young children to be lying down below the microscope. So taking this forward, is this law which was put forward way back in the 1960s, when the Bunsen-Roscoe law of reciprocity, which said that the photochemical effect would be similar as long as the total fluence remains constant. So what does this mean? We need to deliver a total energy of 5.4 joules per centimeter squared. So instead of the 3 milliwatt for 30 minutes, you can go ahead with different accelerated protocols like 9 milliwatt for 10 minutes, 18 milliwatt for 5 minutes, 30 for 3 and 45 for 2. Basically, all of them need to add up to a total energy of 5.4 joules per centimeter squared to give rise to the same photochemical effect. It has been shown in different studies that greater than 45 millimeter per centimeter squared does not lead to any increase in biomechanical strength, the theory behind which we will discuss subsequently. Now all this first in physics is fine, but how does it work out in practice? Let us look at what the studies have to say as far as accelerated versus conventional protocols are concerned. So looking at the outcomes, first being the safety, all protocols achieve the primary target of causing an arrest in progression of keratoconus, be it any protocol. Though some rare case reports of progression despite the 18 and 30 milliwatt protocols have been shown, by and large all of them have shown an arrest in progression of keratoconus. In terms of visual acuity, though no statistically significant difference has been shown, there is a trend towards a greater visual acuity gain through the 3 and 9 milliwatt protocols. When we look at keratometry, significantly more flattening is achieved with the 3 milliwatt protocol, and there is a progressive decrease with the 9, 18 and 30 milliwatts, stating that the maximum amount of flattening is achieved with a slower protocol as compared to the most accelerated forms. Depth of demarcation line being a surrogate measure of the amount of or the depth of cross-linking also is deepest with the 3 and 9 milliwatt per centimeter squared, and the 3 and 9 milliwatt protocols give you a continuous demarcation line, whereas it becomes patchy and more diffuse with the 18 and 30 milliwatt protocols. So what is the basis for this? Why is there a difference when we expect the photochemical effect to be the same? Why is it different with different protocols? As you all know, the cross-linking happens through two mechanisms. Type 1, which is an anaerobic form, which is more of the minor actually part of the cross-linking, and the type 2 is the aerobic or the major part of the cross-linking. And as this is an oxygen dependent process and leads to the production of reactive oxygen radicals, and which then leads to the formation of cross bridges, the depletion of oxygen in the accelerated protocol, when there is a large amount of energy delivery, this oxygen gets rapidly depleted, and this subsequently leads to a restricted type 1 type of cross-linking, and therefore the extent of cross-linking and the extent of flattening which takes place becomes lesser, and this is most likely the theory behind the decreased efficacy with the higher energy and extremely fast protocols. So to overcome this, a pulsed versus continuous regimen was put forward. A continuous regimen where the 30 milliwatt is continuously delivered over 4 minutes, whereas in the pulsed regimen it's delivered over 8 minutes, where it's pulsed for 1 second on and 1 second off. So 1 second there is energy delivery, and for the other second it's switched off, and the 1 second it comes on again. So because of this pulsed delivery, this on and off interval gives time for the oxygen to be replenished, and thereby leading a type 2 photochemical reaction to take place and a more effective cross-linking to happen. Studies have shown that this pulsed protocol gives rise to deeper demarcation lines, greater flattening, and a similar safety profile. So moving on to accelerated protocols, where accelerated protocols are now being combined with laser vision correction. Can we achieve a biomechanical strengthening without causing a refractive effect? Major problems following any refractive procedure are iatrogenic ectasia and regression, which no refractive surgeon wants to have. So is there some way where we can strengthen the cornea and prevent these two complications? Combining these have their own concerns. The long-term safety is not yet proven. What kind of refractive effect will the CXL have? As you all know, the standard CXL causes a flattening over a period of time over 1 year. So will this lead to increased haze and scatter and progressive flattening and overcorrection in our patients with laser vision correction, which we do not want? So what can be the indications? Any younger patients, patients with high myopia or high hyperopia where we expect more regression to happen, borderline topographies of history of keratoconus or treatments who are more prone to achieving iatrogenic ectasia. How is this accelerated CXL combined with LVC? So this is basically, instead of the 0.1 riboflavin, a 0.25% riboflavin is used, and the total energy delivery, instead of 5.4, it is reduced to 2.7 joules, and with a very rapid irradiation time of 90 seconds. So what we aim to achieve through this is achieving a strengthening, a corneal strengthening without inducing a refractive effect. In LASIK, it's important not to do the cross-linking through the flap or administer the drops through the flap, because we don't want to cross-link the flap, which doesn't add any biomechanical strength to the cornea itself, but in fact could lead to flap shrinkage and complications later. Accelerated CXL with LVC has shown to have greater refractive accuracy in higher myopic patients, excellent stability with hyperopic patients with minimal extent of regression, and no progressive flattening. And this is the kind of effect which has been shown in finite element models, wherein the amount of protrusion which is caused in a cross-linked cornea with the IOP shift is much more minimal. Thereby, the myopic regression also happens to be less. Therefore, accelerated CXL is an effective form of treatment, needs longer follow-up in terms of combining it with LVC, and especially in very young age groups and in pediatric patients. Possibly in the future, we may have tailor-made cross-linkings, wherein early and mild keratoconic forms where we don't want much flattening and just want to strengthening and preventing the progression of keratoconus, we may have the more rapid protocols, and wherein a little more advanced keratoconus where we want a more significant flattening to take place, maybe stick to the standard protocols. Thank you.